Everything you need to know about TVS diode, transient voltage suppression diode. A transient voltage suppression, TVS, diode is a specialized electronic component designed to protect circuits from transient voltage spikes, such as those caused by electrostatic discharge, ESD, lightning strikes, power surges, and inductive load switching. TVS diodes are essential for safeguarding sensitive electronic components in a wide variety of applications by clamping or limiting excessive voltage levels to prevent damage. Key characteristics of TVS diodes. Voltage clamping refers to the ability of a device, such as a TVS diode, to limit or clamp the voltage in a circuit to a safe level when it exceeds a predetermined threshold. This is a critical feature in protecting sensitive electronic components from being damaged by transient overvoltages, such as those caused by electrostatic discharge, ESD, lightning, or inductive load switching. How voltage clamping works in TVS diodes. Normal operation. Under normal operating conditions, the TVS diode remains non-conductive. It has a very high impedance and does not affect the circuit when the voltage is within the specified range. Overvoltage condition. When the voltage spike occurs and the circuit experiences a transient event that pushes the voltage beyond a certain threshold, known as the breakdown voltage of the TVS diode, the diode becomes conductive. Clamping action. Once the voltage exceeds this breakdown point, the TVS diode clamps the voltage by conducting the excess energy to ground. It limits the voltage to a clamping voltage that is just above the normal operating voltage, preventing it from rising higher and potentially damaging the components in the circuit. Energy dissipation. The TVS diode absorbs and dissipates the excess energy from the transient event as heat, protecting the circuit from the potentially harmful voltage spike. Return to normal state. After the transient event passes and the voltage returns to a safe level, the TVS diode becomes non-conductive again and returns to its high impedance state. Key points of voltage clamping. Breakdown voltage. The voltage at which the TVS diode begins to conduct and clamp the voltage. Clamping voltage. The voltage level to which the TVS diode limits the spike. This is slightly higher than the breakdown voltage. Response time. TVS diodes respond extremely quickly, in nanoseconds or picoseconds, to voltage spikes, ensuring protection before the transient can damage the circuit. In summary, voltage clamping in TVS diodes prevents harmful overvoltage conditions by quickly responding to transients and limiting the voltage to a safe level, protecting sensitive electronic components. Fast response time refers to how quickly a protective device, like a TVS diode, can react to an overvoltage condition or a transient voltage event. In the context of TVS diodes, a fast response time is crucial for safeguarding sensitive electronic components from damage caused by transient voltage spikes, such as electrostatic discharge, ESD, lightning surges, or inductive switching events. Characteristics of fast response time in TVS diodes. Timescale. TVS diodes typically respond in the nanosecond to picosecond range. This ultra-fast response ensures that the diode activates before the transient voltage spike has time to reach and potentially damage sensitive components in the circuit. Instant activation. The TVS diode remains inactive under normal operating conditions, but as soon as the voltage exceeds the diode's breakdown voltage, it instantly becomes conductive, diverting the excess voltage away from the protected circuitry. This near-instant activation is what defines the fast response time of the diode. Transient suppression. Because transient voltage events are often very brief, lasting microseconds or nanoseconds, a slow response time would allow the transient to reach and harm the protected components. A fast response time ensures that the transient is clamped or dissipated before it causes any damage. Critical for sensitive electronics. Devices such as microcontrollers, processors, memory chips, and communication interfaces, USB, Ethernet, HDMI, etc., are highly sensitive to overvoltage conditions. TVS diodes with fast response times are necessary to protect these components, especially in environments where voltage spikes can occur suddenly and without warning. Importance of fast response time. Protection against ESD. Electrostatic discharge, ESD, events can cause voltage spikes that occur in just nanoseconds. TVS diodes with fast response times can quickly clamp these spikes and prevent damage to sensitive inputs, such as USB ports or communication lines. Lightning and power surges. In cases where lightning-induced surges or power line disturbances occur, TVS diodes can react fast enough to protect equipment like network routers, industrial controls, or consumer electronics from these sudden voltage increases. High-speed data lines, high-speed communication interfaces like HDMI, USB 3.0, Ethernet, and PCI Express require protection from voltage spikes without causing interference or signal degradation. The fast response of TVS diodes helps suppress voltage transients without affecting the integrity of high-frequency signals. Continuous circuit integrity. A slow response could allow a significant portion of the transient voltage to pass through to the circuit, causing degradation or damage. Fast response time ensures that the transient is clamped before it can harm the circuit, maintaining the reliability of the system. Example of fast response time. Consider a scenario where an external device is plugged into a USB port. During the connection process, a static discharge, ESD, occurs, causing a rapid voltage spike on the data lines. A TVS diode with a response time in the nanosecond range quickly clamps the voltage to a safe level before the surge can reach the internal electronics, ensuring that the computer or mobile device remains undamaged. Comparison to other protection methods. Fuses. While fuses provide overcurrent protection, they are much slower to respond, milliseconds or longer, and are unsuitable for handling fast transient voltage spikes. MOVs, metal oxide varistors, MOVs also protect against voltage surges, but they are slower than TVS diodes and are better suited for longer duration surges, such as those caused by power line disturbances. In summary, fast response time is a critical feature of TVS diodes, allowing them to protect sensitive electronic components from sudden, short-duration voltage transients. This fast reaction prevents circuit damage and ensures the continued safe operation of electronic systems. Bidirectional and unidirectional protection refers to the two main configurations of TVS diodes designed to handle transient voltage spikes, depending on whether the protected circuit operates with unidirectional or bidirectional voltage signals. The choice between these two configurations depends on the nature of the voltage signals in the circuit and the type of protection required. 1. Unidirectional protection. Unidirectional TVS diodes are designed to protect circuits where voltage transients are expected to occur in only one polarity, typically in circuits that carry DC or signals where the voltage is not expected to reverse polarity. Key features. Polarized clamping. Unidirectional TVS diodes clamp voltage transients that go above a certain threshold in one direction, positive or negative. If the transient exceeds the breakdown voltage in the forward direction, the diode becomes conductive and clamps the voltage. Reverse breakdown. In the reverse direction, where the voltage is negative in a normally positive bias circuit, the diode stays in its non-conductive state until the breakdown voltage is reached. Applications. DC power supply circuits. These diodes are often used in circuits with a stable DC voltage, such as power supplies, battery charging circuits, and automotive DC systems. Sensitive IC protection. Unidirectional TVS diodes are used to protect integrated circuits, ICs, from positive voltage surges while maintaining normal operation in the positive range. Microcontrollers. Many digital circuits, including microcontrollers, operate with unidirectional signals, making this type of diode useful in preventing damage from positive voltage spikes. Example. In a DC power supply circuit, where the operating voltage is 5V, a unidirectional TVS diode might be rated to clamp voltages higher than 6V. If a surge occurs and the voltage exceeds 6V, the diode will clamp it, protecting the downstream components. 2. Bidirectional protection. Bidirectional TVS diodes are used to protect circuits where voltage transients may occur in both polarities, typically in circuits with AC signals, or where voltage swings occur in both positive and negative directions. Key features. Symmetrical clamping. Bidirectional TVS diodes provide symmetrical protection for both positive and negative transients. When the voltage exceeds the breakdown voltage in either direction, the diode clamps the spike, regardless of its polarity. Non-polarized. These diodes are non-polarized, meaning they can suppress voltage spikes in both directions. Applications. AC circuits. Bidirectional TVS diodes are ideal for protecting AC power lines and communication lines where the voltage swings from positive to negative during operation. Data transmission lines. Many high-speed data lines, like Ethernet, RS-485, and CAN bus, carry signals that swing in both directions. Bidirectional TVS diodes protect these lines from voltage transients without affecting normal data transmission. Analog signal lines. In analog circuits where signal voltages vary above and below a reference point, bidirectional protection is required to clamp spikes in both directions. Example: in an AC power line operating at 120 V RMS, a bidirectional TVS diode may be used to clamp surges above 175 V in both positive and negative polarities, protecting connected devices from spikes during power fluctuations or lightning strikes. Comparison of bidirectional and unidirectional TVS diodes. Feature unidirectional TVS diode, bidirectional TVS diode. Voltage handling protects against voltage spikes in one direction, positive or negative. Protects against voltage spikes in both positive and negative directions. Polarity polarized, must be installed with correct orientation in the circuit. Non-polarized, can be installed either way in the circuit. Applications: DC circuits, battery-powered devices, unidirectional data lines. AC circuits, data transmission lines, Ethernet, CAN bus, analog signal circuits. Clamping action clamps transients only in one direction. Clamps transients symmetrically in both directions. Examples: microcontroller power supplies, automotive electronics, AC power protection, network interfaces, communication lines. Summary: unidirectional protection is suitable for DC and one-way voltage circuits, where the diode only needs to clamp surges in one direction. Bidirectional protection is ideal for AC or bidirectional circuits, where voltage can swing both positively and negatively, and protection is needed for both polarities. Choosing between the two types of TVS diodes depends on the characteristics of the circuit, the nature of the voltage signal, and the type of transient voltages that may occur. Low clamping voltage refers to the ability of a protective device, like a TVS diode, to limit a transient voltage to a lower level while still providing effective protection for the circuit. It is an important characteristic, especially for protecting sensitive electronic components that can only tolerate small voltage variations above their normal operating levels. Definition of clamping voltage. The clamping voltage is the maximum voltage that a TVS diode allows across the protected component during a transient event. After the TVS diode begins conducting due to a voltage spike, once the breakdown voltage is exceeded, it clamps the transient voltage to this clamping voltage, ensuring that the excess energy is safely dissipated. Importance of low clamping voltage. Sensitive electronics. Modern electronics, especially devices like microcontrollers, integrated circuits, ICs, memory modules, and data transmission lines, USB, HDMI, Ethernet, operate at lower voltages, 1.8 V, 3.3 V, 5 V, etc. These components cannot withstand high overvoltages, so protection devices need a low clamping voltage to prevent any potential damage. Minimal voltage stress. A lower clamping voltage ensures that the voltage spike is reduced to a safe level that the circuit can handle. If the clamping voltage is too high, the transient could still damage components, even though the TVS diode is in action. Efficient protection. By clamping at a lower voltage, the diode activates earlier and reduces the duration and intensity of the transient voltage exposure, minimizing the risk of degradation or destruction of the protected component. Key aspects of low clamping voltage in TVS diodes. Breakdown voltage versus clamping voltage. Breakdown voltage. The voltage at which the TVS diode begins to conduct current and enter the protection mode. For example, a TVS diode might have a breakdown voltage of 6 V. Clamping voltage. Once the diode starts conducting, it limits the voltage to a certain maximum value. In the case of a low clamping voltage, this might be just slightly above the breakdown voltage. For example, if the breakdown voltage is 6 V, the clamping voltage might be 7 V or 8 V. Response speed. TVS diodes with low clamping voltages tend to respond extremely quickly, in nanoseconds or picoseconds, meaning they are capable of reacting to voltage spikes before any significant damage can occur. Power dissipation. A TVS diode with a low clamping voltage is designed to absorb the excess energy generated by the voltage spike and dissipate it as heat, thereby protecting the circuit. Low clamping voltage diodes are especially critical for circuits with tight tolerances and small margins of acceptable voltage deviation. Applications of TVS diodes with low clamping voltage. Consumer electronics. Devices like smartphones, laptops, tablets, and wearables require protection circuits that can clamp voltages at very low levels due to the sensitive nature of their internal components that operate at low voltages, e.g., 1.8 V, 3.3 V. Data and communication interfaces, USB, HDMI, Ethernet, and other communication protocols that operate at low signal voltages need low clamping voltage TVS diodes to protect against electrostatic discharge, ESD, or voltage surges without interfering with the signal integrity. Automotive electronics. Modern vehicles have low-voltage control circuits that must be protected from transients, particularly in electric vehicles, EVs, and hybrid systems, where sensitive sensors and control modules require low clamping voltage protection. Microprocessors and ICs. Microprocessors and integrated circuits are very sensitive to overvoltages, and even small voltage spikes can cause damage or data corruption. TVS diodes with low clamping voltages are essential in these applications to ensure reliable operation. Example: consider a USB 3.0 interface, where the data lines operate at around 3.3 V. A low clamping voltage TVS diode might be used with a breakdown voltage of 3.6 V and a clamping voltage of 4.5 V. This ensures that any transient voltage above 4.5 V is clamped, protecting the USB interface and connected devices from damage. Comparison with high clamping voltage. Feature low clamping voltage, high clamping voltage. Voltage protection suitable for low voltage devices and circuits. Suitable for high voltage power systems or industrial circuits. Application: consumer electronics, microcontrollers, data lines, power systems, large motors, heavy-duty industrial electronics. Response speed: ultra-fast response, nanoseconds. Fast, but may not be suitable for very sensitive low-voltage circuits. Component protection offers fine protection for sensitive components. Protects components that can tolerate higher voltage swings. Conclusion: low clamping voltage is a critical characteristic for TVS diodes in applications that require protection of low-voltage circuits. It ensures the diode reacts quickly and clamps transient voltages to safe levels, preventing potential damage to sensitive electronics while maintaining circuit integrity. High power handling refers to the ability of a TVS diode to absorb and dissipate a large amount of energy from a transient voltage spike without being damaged or degraded. This characteristic is critical when protecting circuits from high-energy transients, such as those caused by lightning strikes, power surges, or industrial equipment switching. Definition of power handling. Power handling in a TVS diode is typically measured in peak pulse power dissipation, often given in watts or kilowatts, which indicates the maximum amount of power the diode can absorb and safely dissipate during a transient event. A high power handling capacity means the TVS diode can protect against strong voltage surges that deliver significant energy in a short period. Importance of high power handling. Protection from large voltage surges. In environments where large voltage spikes are common, such as industrial machinery, automotive systems, or outdoor installations, a TVS diode with high power handling ensures that even large surges are safely clamped without damaging the diode or the protected circuit. Longer durability. High power handling TVS diodes can handle repeated high-energy transient events without failure, providing longer-lasting protection. This makes them ideal for applications where frequent voltage transients are expected. Clamping high-energy surges. High-power transients, such as those caused by lightning or major power disturbances, carry a significant amount of energy. TVS diodes with high power handling capabilities clamp these surges efficiently, preventing high-voltage transients from reaching sensitive components in the system. Key characteristics of TVS diodes with high power handling. Peak pulse power rating, PPP. The most important specification for high-power TVS diodes is the peak pulse power rating, PPP, which defines how much power the diode can handle during a transient event. High-power handling TVS diodes may have power ratings in the kilowatt, kW range, with some reaching up to 30 kilowatts or more for brief durations. Pulse duration. The power handling capacity is also influenced by the duration of the transient. TVS diodes are typically rated for specific pulse durations, such as 10 out of 1000 ms, microseconds. A high-power handling diode will be able to safely dissipate large amounts of energy over short time intervals. Thermal dissipation. High-power handling TVS diodes are designed to dissipate the absorbed energy as heat efficiently. The larger the surge they can handle, the more heat they must dissipate. These diodes are often larger or may require heat sinks in extreme environments. Breakdown and clamping voltage. Even with high-power handling, these diodes are still designed with specific breakdown and clamping voltages to ensure they protect the circuit at the correct levels. However, they are optimized to maintain clamping voltage under extreme conditions without allowing excessive voltage through. Applications of high-power handling TVS diodes. Lightning protection. High-power TVS diodes are commonly used in applications requiring protection against lightning-induced surges, such as outdoor communication systems, power lines, and infrastructure that is exposed to harsh environmental conditions. Industrial equipment. Industrial equipment often experiences large voltage transients due to switching of large inductive loads, such as motors and transformers. TVS diodes with high power handling are used to protect control circuits, power supplies, and interfaces in these environments. Automotive and aerospace. Automotive systems, particularly in electric and hybrid vehicles, experience power surges due to alternators, ignition systems, and other large electrical loads. High-power TVS diodes are crucial for protecting onboard electronics and safety systems from these transients. Power distribution systems, power lines, substations, and renewable energy systems, such as solar inverters and wind turbines, are prone to high-energy surges. High-power TVS diodes provide robust protection for the sensitive electronics that control these systems. Communication infrastructure. In telecommunications and data networks, large surges caused by lightning or power cross faults can damage expensive infrastructure. High-power TVS diodes are used to safeguard networking equipment such as routers, switches, and base stations from these high-energy transients. Example of high-power handling TVS diode. Consider a high-power industrial application, such as an outdoor communication tower, which is susceptible to lightning strikes. A TVS diode with a peak pulse power rating of 15 kilowatts for 10/1000 US pulses might be installed to protect the control electronics. In the event of a lightning surge, the diode can absorb the high energy, clamp the voltage spike, and prevent damage to the sensitive components in the system. Comparison between low and high power handling TVS diodes. Feature low power handling TVS diode, high power handling TVS diode. Power dissipation typically rated for low energy transients, e.g., ESD protection. Rated for high energy transients, such as lightning or industrial surges. Applications: consumer electronics, data lines, low power devices, industrial systems, power grids, automotive, lightning protection. Peak pulse power rating: lower ratings, typically in the hundreds of watts range. Higher ratings, typically in the kilowatt range. Physical size: smaller, suited for compact circuits. Larger, may require heat dissipation or heat sinks for large energy absorption. Pulse duration: designed for short duration pulses, such as ESD, nanoseconds to microseconds. Designed for longer duration pulses, such as power surges, microseconds to milliseconds. Conclusion: high-power handling TVS diodes are essential for protecting circuits from high-energy transients like lightning strikes, power surges, or industrial equipment switching. With their ability to absorb and dissipate large amounts of energy in a short time, they safeguard sensitive electronic components in harsh environments and critical systems. Their robust design ensures long-term durability and reliable protection, making them indispensable in industries that deal with high-power and high-voltage transients. Applications of TVS diode. ESD protection. TVS diodes are commonly used to protect sensitive electronic components from electrostatic discharge, ESD, which can occur due to human contact, handling, or environmental factors. Data and communication lines. In digital communication systems, Ethernet, USB, HDMI, etc., TVS diodes protect data lines from voltage spikes caused by external factors like lightning or static discharge. Automotive electronics. Automotive systems are prone to voltage transients due to switching inductive loads like motors and solenoids. TVS diodes are used in automotive electronic control units, ECUs, to protect microcontrollers and other components. Power supplies and AC circuits. TVS diodes are used in power supply circuits to safeguard components from overvoltage conditions or lightning-induced surges, particularly in AC main circuits. Telecommunication equipment, telephone and network lines, due to their long-distance wiring, are vulnerable to transients from lightning or power crossfaults. TVS diodes are used in these systems to protect the sensitive communication electronics. Industrial control systems. In factory automation and control systems, which often involve switching high power loads, TVS diodes prevent voltage spikes from damaging control circuits. Consumer electronics. Devices such as smartphones, laptops, gaming consoles, and other consumer gadgets use TVS diodes to protect their internal circuits from voltage surges, particularly from external interfaces, e.g., USB ports, HDMI inputs. Military and aerospace applications. TVS diodes are used in mission-critical systems in military and aerospace electronics, where high reliability and protection from extreme electrical conditions are required. In summary, the TVS diode is an essential protection component in electronics, acting as a first line of defense against transient voltage spikes that could otherwise cause failure or degradation of sensitive circuitry.